For weeks, astronomers have been tracking the mysterious interstellar object known as 3I Atlas. But now, something unexpected has happened. It has disappeared behind the sun. No one knows exactly what is going on. Is it a simple orbital phenomenon or something much stranger? If you're watching this video, it's because, like us, you're fascinated by the mysteries of the universe. Today, we'll talk about a visitor that came from the depths of space and suddenly disappeared without a trace. An object so strange that some astronomers don't know whether to classify it as a comet, an asteroid, or something else entirely. Stay until the end, because what's happening with 3I Atlas could change our understanding of what lies beyond the solar system. And before you begin, make sure you subscribe and activate the bell, because on this channel we follow the most perplexing phenomena of the cosmos every week. Now then, let's get the telescope ready, because the story of 3I Atlas is about to become even more mysterious. 3I Atlas was first detected in early 2024 when a team of astronomers using the ATLAS system, a network of automated telescopes dedicated to tracking near-Earth objects, noticed something unusual, a point of light moving at a speed and in a direction impossible for an ordinary comet. Calculating its trajectory, they discovered it wasn't gravitationally bound to the sun. It was an interstellar visitor, the third in the history of modern astronomy, following the now famous cases of Oumuamua and Borisov. That discovery sparked the curiosity of the scientific community because each such object is a time capsule from another star system, a unique opportunity to study matter beyond the confines of our cosmic neighborhood. As more observations were obtained, the data began to reveal that 3I Atlas was not a simple comet of ice and dust. Its brightness was not stable. It varied irregularly, sometimes with sudden flashes and other times with an almost total disappearance. Some suggested it might be a metallic surface or have unusual reflective properties, while others thought of fragments, cracks, or jets of gas being ejected chaotically. The fact is, it was unlike anything we had ever seen before. Its speed was also puzzling. It was moving at more than 26 kilometers per second, fast enough to escape the solar system without the sun's gravity being able to hold it. Its entry angle indicated an origin beyond the known regions of the Milky Way, perhaps from an interstellar cloud or a distant star system, maybe destroyed millions of years ago. It was, in essence, a messenger from deep space. The excitement among astronomers was immense. Every time an object like this appears, it represents a fleeting window, a brief moment to learn something about the matter forming elsewhere in the universe. But it was also a challenge. Its movement was rapid, its observation difficult, and the instruments could barely track it. Within weeks, 3I Atlas was already in a critical position, approaching the sun from an angle that complicated its monitoring. No one imagined then that, upon passing behind the sun, it would simply vanish. Until very recently, humanity believed that interstellar objects were so rare that we would probably never see one up close. For decades, our telescopes tracked millions of asteroids and comets, all born in our own solar system. But in 2017, something changed forever. A small, elongated body, detected by the Pan-STARRS telescope in Hawaii, burst onto the scene. It was dubbed Oumuamua. The word Earth comes from Hawaii and means messenger from afar who arrives first. Its orbit revealed something extraordinary. It didn't revolve around the sun like the others, but came from outside, crossing the solar system at a speed so high that no local object could match it. It was the first confirmed interstellar visitor in modern history. Oumuamua baffled everyone. It had no gas tail like comets. Its shape appeared extremely elongated, and its brightness changed rhythmically, as if rotating and showing different faces to the sunlight. Most unsettling was that its trajectory showed anomalous acceleration, an impulse that could not be explained by simple gravity. Some scientists spoke of an ejection of invisible gas, others of an effect of solar radiation pressure on an object with a very thin structure, almost like a candle. And a few, led by the astrophysicist Avi Reeds from Harvard, they dared to suggest something bolder, that it could be an interstellar probe manufactured by another civilization. Just 2 years later, in 2019, another visitor crossed our sky. The comet U-I Borisov, discovered by amateur astronomer Gennady Borisov from Crimea. Borisov, unlike Oumuamua, did resemble a classic comet. It had a bright coma, a long dust tail, and predictable chemical behavior. But its origin was equally surprising. It came from another star. In just 2 years, humanity had detected 2 interstellar objects. What had once seemed impossible became a new branch of astronomy, the study of interstellar objects, messengers from deep space. However, when it appeared, Atlas scientists immediately noticed that something didn't fit the pattern. If Borisov had been a normal visitor and Oumuamua an unprecedented enigma, 3I Atlas seemed to fall somewhere in between, neither a conventional comet nor an inert rock. Its fluctuating brightness, its bluish-green color, and its hyperbolic trajectory reinforced the idea that something different was happening. Its surface seemed to reflect sunlight with a metallic sheen, as if it had an unusual composition or an irregular geometry. Astronomers began to wonder if we were witnessing a new category of visitors. What if interstellar space were filled with fragments, debris, and artifacts that wander among the stars, occasionally crossing our solar system unnoticed? Some calculations estimate that they could exist, billions of these objects crossing the galaxy, invisible to our telescopes, and of which only a tiny fraction is detected. Each one would be a letter sent from another corner of the universe, written with materials that do not exist on Earth, with stories of long-extinct suns and planets that may once have harbored life. Thus, when 3I Atlas appeared in observatory records, astronomers knew they were looking at something special. It represented a unique opportunity. The third confirmed interstellar visitor, the third time we could closely observe a traveler that literally came from the stars. But its passage would be brief. Its orbit would take it close to the sun, and then, like the previous ones, it would disappear into the interstellar void. What no one imagined was that, even before leaving our field of vision, I-Atlas would mysteriously vanish behind the sun, leaving behind more questions than answers. With its disappearance, the story of interstellar objects once again became uncertain. Each new visitor seemed to deepen the mystery rather than solve it. First came Oumuamua, which broke the laws of dynamics, then Borisov, which confirmed the existence of natural travelers. And now, 3I Atlas, a body that seemed to combine features of both, but with behavior that defied all prediction. In barely a decade, we went from believing we would never see an object from another star system to discovering 3, each more enigmatic than the last. What are these messengers trying to tell us? And why, just when we most needed to observe it, did the last one vanish in the sun's scorching light? During the first few weeks of observation, everything seemed as expected. Calculations of 3I Atlas's trajectory were updated nightly with pinpoint accuracy. Telescopes in the northern and southern hemispheres coordinated tracking shifts, and the scientific community experienced a brief but intense period of enthusiasm. However, around the middle of its passage through the inner solar system, something began to worry observers. The apparent magnitude of 3I Atlas, its brightness as seen from Earth, began to vary with unusual rapidity. In a matter of days, the object became increasingly faint until, suddenly, it disappeared from the optical record. Astronomers knew that its position led it to pass behind the sun from our perspective, a region impossible to observe directly due to solar glare. But this time, the predictions didn't quite match up. Normally, when a comet or asteroid passes behind the sun, orbital calculations allow us to know exactly where and when it will reappear. However, in this case, the ephemerides began to show slight deviations. The expected reappearance position changed every day, as if something had altered its course during the solar transit. Observatories in the southern hemisphere, which should have been the first to detect it again, pointed their instruments at the predicted location and found nothing. Not a trace of the object, no optical signature, no flash, no sign of dust or fragmentation. It was as if 3I Atlas had completely vanished. Speculation began in amateur astronomy forums and independent research groups. Some suggested it was simply a temporary loss of signal. The sun emits such an overwhelming amount of radiation that it can blind even the best sensors. Others, more cautious, began to notice small inconsistencies in the data prior to the disappearance. The exit velocity seemed slightly higher than predicted, and the direction a few degrees off from what gravitational models dictated. A minuscule change, yes, but enough to alter its future trajectory and cause the object to leave the expected search area. The teams that operate the satellites SOHO and STEREO, the satellites that constantly observe the sun and its surroundings, reviewed their images for any sign. Occasionally, these satellites managed to record comets disintegrating or flying past the sun in spectacular luminous collisions. But in the archives corresponding to the passage of 3I Atlas, nothing appeared, not a trail, not a cloud of dust, not a detectable thermal signature. If the object had indeed passed behind the sun, its transit had been completely silent, invisible even to the most sensitive eyes in the solar system. This silence baffled astronomers. A body with the characteristics of 3I Atlas should have left some kind of trace, a gas ejection, a change in the light spectrum, an alteration in its brightness curve. But the instruments recorded absolutely nothing. Some scientists began to consider the possibility that the object had fragmented upon getting too close to the sun's heat, as happens with some comets that cannot withstand the radiation and disintegrate into microscopic particles. However, if that had been the case, SOHO's sensors should have detected an increase in particles or a dust cloud, and they didn't. Meanwhile, computer simulations attempted to reconstruct what might have happened. If the observed deviation before the transit was real, it meant that a non-gravitational force had acted on the object. Perhaps an unexpected gas emission, or maybe a collision with micrometeorites that altered its course. But there was also a more perplexing hypothesis. An acceleration with no apparent cause, similar to that shown by Oumuamua in 2017. That coincidence led many to wonder if we were witnessing a phenomenon that repeated itself with each interstellar visitor. As the days passed and 3I Atlas failed to reappear, the mystery deepened. Predictions indicated that it should be visible again from observatories in Chile, South Africa, or Australia by then. However, the sky remained empty. It was as if the object had slipped behind the sun and somehow decided not to emerge. Some media outlets began covering the story with sensational headlines. Interstellar object disappears behind the sun. 3I Atlas, the vanishing visitor. Astronomical error or unexplained phenomenon. And while most scientists remained calm, no one could deny that something unusual was happening. The disappearance of 3I Atlas marked a turning point, not only because the opportunity to study a unique object was lost, but also because the event reopened an old debate. Do we really understand what happens when a body from another star system interacts with our own? If we can't even predict with certainty where it will reappear, what other mysteries might be hidden in its brief passage through our solar neighborhood? The only thing clear was that the sun, in all its brilliance, had once again swallowed a secret, and that, on the other side of its blinding light, 3I Atlas might be doing something we don't yet understand. For more conservative astronomers, the most reasonable explanation was also the simplest: an error in the data. Space, despite all the technological precision of our era, remains an environment where a minute variation can alter an entire calculation. Moreover, the sun is not simply a bright point in the sky. It is a colossal source of electromagnetic radiation that can distort instruments, saturate optical sensors, and interfere with communication signals between telescopes and satellites. When an object passes too close to its glare, even the most sophisticated observations can become unreliable. In the case of 3I Atlas, this hypothesis seemed to make sense. The Atlas telescope, along with the Pan-STARRS system and other observatories, had been collecting data at the limit of its sensitivity. The object was faint, with variable brightness, and in the final nights before it disappeared, its position was estimated with increasingly larger margins of error. Astronomers knew that, as it approached the sun, CCD detectors could become saturated by the extreme brightness of the background. A simple deviation of a few tenths of a degree in the telescope's orientation or a single instance of solar interference could have caused the system to lose visual contact with the object. Furthermore, the sun doesn't just emit visible light, its electromagnetic field extends over a range that directly affects the equipment. Ultraviolet, infrared, and X-ray radiation sensors must be constantly calibrated, and when an interstellar object passes through the region near the solar disk, the electromagnetic turbulence intensifies. In this chaos of data, a signal as weak as that of 3I Atlas could easily be mistaken for noise. In fact, it wouldn't be the first time this has happened. Numerous comets have been temporarily lost during their solar transits, only to reappear weeks later in a slightly different position than predicted. Proponents of this theory also recalled the so-called Kreutz comets, a family of icy bodies that pass extremely close to the sun and often disintegrate. During their transits, instruments often register false positives or even complete signal loss. Astronomers from NASA and ESL, accustomed to these events, insisted that there was no need to jump to conclusions about anomalies or cosmic mysteries. Probably, they said, 3I Atlas had simply been hidden behind the solar disk and would reappear once it emerged from the glare. It was just a matter of waiting a few more days. However, as time passed and no new detections were made, the instrumental error theory began to falter. If the signal loss was solely due to solar interference, the observatories should have seen it again as soon as the object moved out of the blind spot. But the telescopes continued to be pointed at its predicted trajectory, and the sky remained empty. Some specialists proposed that the error lay not in the observation itself, but in the initial orbital calculation. Perhaps the hyperbolic trajectory of 3I Atlas had been misinterpreted due to a lack of data, and what we believed to be an exit heading was actually a different angle, causing the object to move out of the field of view of ground-based telescopes. Others raised an even more mundane possibility that the object's brightness had diminished completely, rendering it undetectable. If 3I Atlas lost part of its reflective surface, or if it ejected gas and dust irregularly before the solar transit, it could have become virtually invisible, even to the most powerful instruments. In that case, its disappearance would not be mysterious, but a simple matter of luminosity and distance. Even so, those most experienced in celestial dynamics noticed that the numbers didn't quite add up. If it were simply a calibration error or a temporary optical loss, the trajectory errors should be random, not systematic. But the displacements observed before its occultation showed a pattern. A minimal but constant acceleration, difficult to explain through human or technical errors. Despite this, the researchers insisted on remaining cautious. Without solid data, any speculation beyond the technical aspects could lead to hasty conclusions. The general consensus was to wait for the sun to move far enough across the sky for satellites to be able to observe the region free of glare again, and for 3I to Atlas to reappear, just as so many other comets had before. But deep down, a sense of unease ran through the astronomical community. Because if it was all just a mistake, why hadn't any instrument even picked up an echo, a reflection, a shadow of the transiting object? Why hadn't even the satellites designed to monitor that area, SOHO, Stereo, Parker Solar Probe, registered a single visual anomaly? The explanation for the astronomical error offered reassurance, but it also left gaps that were impossible to ignore. Perhaps the telescopes were mistaken, perhaps the sun confused our sensors, or perhaps not. And as the optical silence dragged on, the voices calling for a look beyond the technical explanation began to grow louder. If you're finding this research fascinating and want to continue exploring the secrets of the universe with me, take this opportunity to subscribe to the channel and activate the notification bell. Every week we analyze the latest mysteries of the cosmos, from interstellar objects to James Webb Space Telescope anomalies. So you won't miss out when we reveal what might have really happened with 3I Atlas, because the most surprising thing is yet to come. Now, let's continue with the video. As the days passed without 3I Atlas reappearing, purely technical explanations began to prove insufficient. Orbital calculations prior to the solar transit showed small irregularities which, when projected long-term, indicated a possible deviation in its trajectory. It was a subtle change, barely perceptible in the initial observations, but enough to shift its expected position by tens of thousands of kilometers. Something had altered the object's course while it was hidden behind the sun, and that single idea unleashed a new wave of theories. The first scientific hypothesis was that of a non-gravitational acceleration, the same phenomenon that baffled astronomers in the case of Oumuamua. In theory, when a body passes close to the sun, the radiation and heat cause the ice and volatile compounds on its surface to sublimate, releasing jets of gas that act as small natural propulsion systems. This is what happens with comets. However, 3I Atlas had shown no clear signs of cometary activity. It had no visible tail, nor a bright coma that would indicate evaporation. If it had truly changed its trajectory, then there must be another cause. Some researchers proposed that the object could have been internally fragmented perhaps. As it passed through the region closest to the sun, the thermal pressure and density differences in its structure caused it to crack or release fragments, thus altering its center of mass and its trajectory. This would explain why it wasn't detected again. If it broke into multiple small pieces, none would be bright enough to be seen from Earth. However, there were also no dust clouds or increases in reflectivity, typical signs of fragmentation. Another theory suggested the possibility that 3I Atlas had experienced an unexpected gravitational interaction. Perhaps it was an uncatalogued object, a near-Earth asteroid, a comet, or even a secondary concentration of solar mass, such as a particularly dense plasma ejection. The passage of a wave of solar matter could have altered its momentum, deflecting it slightly from its initial trajectory. Calculations showed that even a minimal variation in speed, on the order of millimeters per second, would be enough to change its apparent course millions of kilometers away. But there was something more unsettling. Some astronomers noticed that the direction of the deflection matched the direction of the push that Oumuamua had shown years earlier. It wasn't a coincidence easily ignored. Both objects shared a hyperbolic trajectory and interstellar origin, and apparently anomalous behavior as they passed near the sun. Was there a pattern? If the three detected objects, Oumuamua, Borisov, and now Atlas, exhibited distinct behaviors, perhaps the third was revealing a clue about the previous two. Simulations began circulating in scientific forums, showing hypothetical scenarios. In some, the object was simply deflected by radiation pressure. In others, an acceleration was observed that could only be explained if the body had an extremely thin shape, similar to a sheet or a sail. This idea sparked controversy. If 3I Atlas had a flat structure, then it could have reacted to solar radiation in the same way a light sail responds to the wind. And if that were true, we would be talking about something more akin to an artificial structure than a natural rock. The proponents of this hypothesis were few, but their argument was provocative. If an advanced civilization wanted to send artifacts between stars, the sun's energy could be used as a source of propulsion. They wouldn't need engines or fuel, just an ultra-thin, reflective material capable of harnessing the impulse of light. What if 3I Atlas was precisely that? A fragment, a relic, a forgotten probe that passed through our system and changed course upon sensing the sun's heat. Of course, the scientific community remained cautious. Most agreed that there was no conclusive evidence of any intentional acceleration. But the fact remained. The object was not where it should have been. Its trajectory did not match the models, and its complete disappearance made it impossible to obtain new data. In astronomy, deviations are rare, and when they are repeated in different objects of interstellar origin, they cease to seem like mere coincidences. While the observatories recalculated, scientists divided their hopes between two scenarios: that 3I Atlas would reappear at some unexpected point in the sky, confirming the change of course, or that it would never be seen again, leaving its story suspended between mystery and physics. In either case, the question was unavoidable. What force, visible or invisible, was capable of altering the path of a traveler from the stars? And it was precisely that question, what invisible force had diverted 3I Atlas, that opened the door to the most controversial theory of all, the possibility that this object it wasn't natural. Although many scientists are reluctant to even consider it, there are precedents that have fueled this idea, starting with the case of Oumuamua. The renowned astrophysicist Avi Reeds from Harvard University was one of the first to suggest that that strange visitor might have been artificial interstellar probia kind of light sail propelled by stellar radiation. At the time, this hypothesis was ridiculed by much of the scientific community, but as new data emerged, some of its observations began to seem less far-fetched. With 3I Atlas, the parallels were unavoidable. Its unstable brightness, its changes in speed, the absence of a cometary tail, and above all, its disappearance behind the sun. Without a trace, everything seemed to repeat the pattern of Oumuamua. Could it be that both objects shared a common origin? If an advanced civilization had developed technology capable of sending artifacts through interstellar space, perhaps we would be observing fragments of the same project or autonomous probes wandering from star to star gathering information. The hypothesis became even more intriguing when some radio astronomers reported electromagnetic anomalies recorded during the days of the solar transit. They weren't intelligent signals nor coded patterns, but rather noise spikes that didn't coincide with normal solar activity. They were brief, repetitive pulses that appeared precisely during the time frame in which 3I Atlas should have been hidden behind the sun. The reports were discrete and mostly classified as residual noise, but for enthusiasts of the Galileo project, the same one led by Loeb, this data was enough to arouse suspicion. According to this line of thought, if 3I Atlas was a probe or technological fragment, its disappearance might not have been accidental. It could have deliberately changed direction or even hidden behind the sun to avoid detection. An improbable maneuver for a natural object, but perfectly logical for a device designed to move with precision through gravitational fields and stellar radiation. The idea is fascinating, even cinematic. A silent spacecraft of unknown origin, using sunlight as a shield to cross the solar system undetected. Of course, science demands evidence, and so far there is none. No unequivocal sign, no fragment, no image to prove that 3I Atlas is anything more than an interstellar rock. But the lack of evidence hasn't stopped human imagination from running wild. The history of astronomy is full of cases where the inexplicable ends up revealing new laws, or where the improbable turns out to be real. Just a century ago, no one believed that cosmic rays, pulsars, or black holes could exist, and today, they are part of our basic understanding of the universe. Furthermore, certain details invite further exploration of the possibility. For example, the specular reflections detected before its disappearance, which appeared to originate from a smooth metallic surface, or the changes in its brightness curve, which displayed almost periodic patterns, as if the object were rotating or reorienting its planes of reflection in a way too precise to be purely random. These behaviors, while not proving anything, do raise the unsettling possibility that we are observing a form of extraterrestrial engineering that we are only beginning to recognize. Of course, the scientific community remains divided. For most, attributing intentionality to a cosmic object without conclusive evidence is an unjustified leap. But even the most skeptical admit that 3I Atlas has raised questions that go beyond orbital physics. What if we had actually detected the remains of non-human technology? What if the vast and ancient universe has been silently leaving these traces in the systems it traverses for millions of years? Meanwhile, the telescopes continue the search. The radio telescope teams at Greenbank, ALMA, and Arecibo, before its collapse, have participated in similar campaigns, trying to capture any repeating signals from future interstellar objects. Space doesn't keep its secrets forever. It only hides them long enough for us to be ready to understand them. And perhaps when 3 Atlas reappears, if it ever does, we will discover that it wasn't just a piece of rock lost in the void, but something that has been traveling for far longer than we can imagine. In the days following the disappearance of 3I Atlas, several observatories continued monitoring the region where it should have reappeared. What they found was unsettling. fragmented data, inconsistent readings, and energy spikes that did not correspond to the solar activity recorded at that time. The first reports came from radio telescopes in South Africa and Chile, which detected unusual fluctuations in microwave frequencies during the exact period when the object should have been hidden behind the sun. These were not clear signals, but brief, irregular pulses, as if something were interfering with the usual cosmic noise. At first, they were thought to be terrestrial interference or normal solar emissions, but the timing of the spikes raised eyebrows. Some analysts noticed that these spikes repeated every few minutes with a periodicity too stable to be random. It wasn't structured communication or a recognizable digital pattern, but rather a rhythmic sequence. The most cautious hypothesis suggested they could be solar plasma discharges reflected by a metallic surface, which would fit with the theory that 3I Atlas had an unusual composition, perhaps rich in rare metals or alloys. Meanwhile, solar observation satellites, OHO and StereoThe, also recorded something anomalous. In several images captured with coronagraphic filters, extremely faint flashes appeared near the area where the object should have been located. They were so subtle that they went unnoticed by the naked eye, but after amplifying the data, the technicians discovered that the flashes followed a curved trajectory, as if something had changed their angle of reflection as they moved. The more skeptical astronomers attributed it to electrically charged dust particles, but others, more boldly, suggested that it could be reflections of a moving structure, perhaps rotating slowly. Interesting things also emerged in the infrared spectrum. The mission's Sensors Parker solar probe scientists studying the solar wind detected slight increases in thermal radiation that appeared to originate from a point source. It wasn't intense enough to be a solar ejection, nor weak enough to be mere background noise. If 3I Atlas had undergone a fragmentation or gas release process, this emission could be explained by the sudden heating of its surface. However, the thermal pattern didn't match that of a decaying body. It appeared and disappeared like a flicker. These scattered and fragmented recordings weren't enough to draw firm conclusions, but they did fuel the feeling that something out of the ordinary was happening. The scientific community avoided making official pronouncements, although in forums of independent researchers and amateur radio operators, the word anomaly was repeated time and again. Some users even claimed to have picked up similar signals with home antennas, which unleashed a wave of theories, from atmospheric reflections to deliberate artificial emissions. In the end, the experts agreed on one thing: the data existed, but it was ambiguous. Nothing that confirmed an artificial nature, but neither was there anything that could completely rule it out. In science, silence also communicates, and in this case, the silence of 3I Atlas seemed full of echoes. An interstellar visitor disappearing behind the sun and leaving behind a trail of impossible readings. It was the kind of mystery that, although lacking definitive proof, opened the door to new questions. Was it just a coincidence that the sensors malfunctioned at that precise moment? Or had we just witnessed, without fully understanding it, a phenomenon that we still don't know how to interpret? As the mystery of 3I Atlas deepened, a question began to resonate with scientists and the curious alike. What does it really mean that these objects are visiting us from the interstellar void? Each time one of them crosses the solar system, it does so after having traveled for millions, perhaps billions, of years through dark, cold regions where time seems to stand still. Every fragment, every particle that composes it, comes from stars that no longer exist, from destroyed systems, or from worlds we will never know. They are messengers of cosmic history, traveling aimlessly until they encounter us by chance. 3I Atlas, like its predecessors, is a reminder that we are not isolated. Solar system is not a sealed bubble, but a transit point in an infinite ocean of matter. The boundary between us and out there is an illusion. The limits of the sun are constantly intertwined with galactic currents that carry dust, rocks, fragments, and perhaps, in some exceptional case, the vestiges of remote civilizations. Their disappearance behind the sun could be, in that sense, a powerful metaphor. The universe still hides more than we are prepared to see. Modern science teaches us that the universe has no intention, but the human heart cannot help but seek meaning. Watching an interstellar visitor cross our stellar neighborhood connects us to something greater, to the idea that the cosmos is not a void, but a living web of intertwined stories. Every celestial body that reaches us brings a message, even if we don't yet know how to read it. And perhaps when the sun stops blinding us and we look in that direction again, we will discover that 3I Atlas was only the first of many more to come. The silence surrounding its disappearance is not an absence, but an invitation. A call to look beyond our certainties, to accept that the universe continues to speak to us in a language we are only beginning to understand. Because ultimately, every time an object like 3I Atlas visits us, what it leaves us with are not answers, but the reminder that we still have much to discover. Today, the whereabouts of 3I Atlas remains a mystery. Observatories have scoured the sky for its trail, but the object has not reappeared. Perhaps it silently disintegrated after passing by the sun, leaving only dust and energy dispersed in the solar winds. Or perhaps in the vastness of space, it changed course, moving away at such speed that we will never see it again. Whatever the truth, something of its story will remain with us forever, the feeling of having witnessed a phenomenon that defies our understanding. Every generation has its own cosmic enigma. In ours, that enigma has a name: 3I Atlas. Its disappearance reminds us that the universe is not made up only of what we can observe, but also of what we lose sight of. Sometimes the most important things happen precisely when we stop looking. Perhaps behind the blinding glare of the sun, there are secrets patiently waiting for the moment when humanity has eyes sharp enough or minds open enough to perceive them. And while we wait for 3I Atlas to reappear, one thing is clear. Every time one of these interstellar travelers crosses our sky, the cosmos is speaking to us. It tells us that we are not the center, that we are part of something vast, dynamic, and in constant motion, that the universe, though silent, always has something to say to those who dare to listen. So now it's your turn. What do you think happened to 3I Atlas? Was it simply a natural object lost among the stars, or proof that we are not alone in the universe? Leave your answer in the comments and share your theory. And if you're as passionate about the mysteries of space as we are, subscribe and activate the bell. On this channel, we'll continue to follow every clue, every anomaly, every visitor that crosses the boundaries of the solar system. Because the next interstellar object might not just leave us with questions, but with the answers we've been waiting for centuries. See you on the next journey amidst the shadows and lights of the cosmos.